Let's go down here to 11 volts. So this short cable works pretty good for 12 volts. Okay, I'm going to test a 15 meter, 16 foot cable for the Starlink Mini. It's an 18 gauge mystery brand. It was 19 bucks. Here it is. There's no marking on the cable. When I go look at the cable with the magnifying glass, there's no marking as far as UL, whatever. So it's a mystery brand. It's just a cheap one I bought for 19 bucks. It's brand new. So I'm going to head and use a linear power supply as the source. And then I've got a electronic load. Now for this test, I shortened up these little leads that connect up to the cable. These are actually 14 gauge, which is pretty beefy. In the last test, they were about 3 feet long. I've shortened them up to be about foot to foot and a half because this cable's a little bit more of a beefier cable and shorter cable. So going to measure the voltage drop and versus power. Okay, there's the 18 gauge 16 foot cable just laying on the floor. Got the linear power supply here, DC, and then I got the Kikusui electronic load. And right now I'm going to start at 35 volts and go down. So I'm going to kick the load on, and that has a load of 30 watts. So this is the DC supply. Got the volts, watts, amps. That's a shunt that's connected up. And then there's the output. So if I crank this up to just about 30 watts. It's not always totally stable because you get some self-heating. We got about 30.3 watts in and about 30 out. So only losing 0.3 of a watt. 0.3 watts at 35 volts. So I'm going to go ahead and drop this to 30 volts. 30 volts is what the stock AC adapter is from Starlink, which is this guy. Put in 100 to 240 volts and you get 30 volts out here, DC at a couple amps. So we've got about an amp here, 30.5 watts. We've got 30 here, so we're losing half a watt. Now we're going to go down and approach like what I would call car batteries, 2 car batteries in series. Maybe with the engine running, like you got this in a truck or something, would be about probably 26, something like that. We got 30.6 watts in, about 30 out. So we're losing 0.6 watts, which is hardly anything. Now this is the voltage at the load. So you go from 26.2 down to 25.7, so it's still pretty good. So we're going to go down here so we're not too boring. Let's go down to 20 volts real quick. Got 31.1 watts in, 30.05 at the load. So you can see here we got 20 volts going in, 19.3. So we're losing 7/10 of a volt, roughly. We're losing about 1.1 watts over 16 feet, which isn't very much. Now we're going to go down here to say 18 volts, like you're running this off of, electric drill power pack, lithium ion, like if you just get one of these modules off eBay to run use a Rigid or Ryobi or Milwaukee or something, generally around 18 volts. You've got 31.3 watts and 30 there, so you're losing 1.3 watts. Still pretty good. Now we're going to go down pretty quickly to 14.4, which is probably like a car roughly with off an accessory plug with the engine running. Kind of a little on the high side because you got the alternator going. Got 32 watts in, 30 out. So you're losing about 2 watts over the wire, 16 feet long. Got 13.5 volts at the load. So you're losing about 9/10 of a volt. So here we are at 13.5 volts in, 32.4 watts, 30. So we're losing 2.4 watts over the 16 feet of cable. Now we're going to go down here and drop to about, say, 12.4. That's kind of like you're just sitting there with the engine off and you got, you're just draining without running the car. You got 30 volts, 30 watts out, and you only got 11.4 here. So you're dropping about a volt across that cable, losing about 2.8 watts. You got 32.8 and about 30. Now we'll just drop down here to 12 real quick and show how it gets worse and worse. 33.1 watts. There's 30, so you're losing 3 watts. Still's happy though. Go down to 11.5, like you're discharging your battery pretty good. Got 33.4. So you're losing 3.4 watts, and you're down to 10.4 here. So you're losing about 1.1 volts across that cable. Let's go down here to 11 volts. So this short cable works pretty good for 12 volts. 33.8 watts. There's 30 watts. So you're really down here below. You got 9.81 volts there. Let's go down to 10.5. Okay, it went down to 10.5 volts here. We got 34.3 watts. 30 watts there. So we're losing 4.3 watts. We're dropping about 1.2 volts across the cable. Go down to 10 volts. Really aggravated. 34.8 watts in. 30 out. We're down to 8.66 volts here. Now I'm going to run another test with the actual unit to see how low it'll go. This is just static test of the cable without the Starlink Mini on there. There's 9.5 volts. Got 35.5 watts. So you're losing 5.5 watts across the cable. Now if let's drop down to 9 volts. You get 36.4 watts into the end cable, 30 out, so we're losing 6.4 watts. We're down to 7.44 volts at the load. We'll go down to 8.5 here. So we got 7.6 watts in, 30 out. So we're losing 6.4 watts, 7.6 watts across the cable, down to 6.81 volts. Now, when I run the test actually on the unit, there's somewhere in here it's just going to crater because it's not just a resistor. You got a regulator probably in the unit. Let's go down to 8 here. 39.4. It's actually 39.5. You're losing 9.5 watts across the cable. Down to 6 volts. Let's go to 7.5. going to heat the floor up here. Now we're 42.5 in, 30 out. So losing 12.5 watts across the cable. And we're dropping 2.2 volts. That's as low as I'm going to go. Well, let me go one more. What the hell? Let's go down to 7 volts. 49. Got 50 watts in, 30 out. Losing 20 watts across the cable. Heating up the floor. Down to 4 volts across the load. Again, this is an electronic load, Kikusui, that you can vary the power that it consumes, or you can use constant resistance. And this is a linear supply, and that's a watt meter measuring the input. That's a shunt.